Okay, this is our code. We need to create a procedure called test random. This tells us what we need to do. This is an example down here of it in action. So pause the video, give it a go yourself first, and then I'm going to show you a solution. Okay, so let's do a speed run through this. We need to know that it's a program language is built in functions such as random numbers. So therefore, I'm going to take a guess. I'm going to do import random. If I don't need it, I'll get rid of it later. You're required to write a program to test random number generator. So it's called test random. Easy. Def test random. Okay. It says repetition as integer, so I'm going to put in here repetition. In my main code, I know that I'm going to need to call test random, and I need to put something in there, but we don't know what yet. It contains a value representing the total number of random numbers that should be generated. Okay, so in my main code, I should be doing this. Random equals random.rand range. Let's do from 1 to does it give us a limit? Well, let's do 1 to let's do 200 to start with to test it out. So let's do random equals 200 because the example gives us is 200 as well. Generate a given number of random between 1 and 10. Okay. So it's actually saying between 1 and 10. We'll change that later. Keep account of the number of times each number is generated. So we need to keep account of how many times number 1's been generated, number 2. So let's actually do 1 and 10. So let's do random.rand range 1 to 10. Okay. Keep account of the number of times each number is generated. So hold on a second. Generate a given number of random numbers between 1 and 10. Keep account of how many times it's generated. Calculate the expected frequency. We'll talk about that in a minute. Actual frequency, output difference. Okay. So the following example shows the output for the procedure called test random 200. Okay. So I'm going to put 200 in here. Inside our procedure, we need to do a random number. One to 10. And we need to do this 200 times. So repetition. So for I in range repetition. So we're going to do this 200 times. Now we need to keep account of how many times each random number has been generated, like number 1, number 2, number 3, number 4, 5, 6, 7, 8, 9, 10. So we need a count. Now, the best way to do this would be in an array. So I'm going to make an array. I'm going to call it number equals square brackets. Well, let's make it a local array. And what I'm going to do is I'm going to fill it up with numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. If random, actually that's going to take forever if I do loads of ifs. So let's think this through. Okay, we want to then increment. So what I'm going to do is this. This will increment every time there's a number 1. So this is going to go 1. So let's imagine it was a number 2 which is generated. This will go up by 1. Let's imagine next time it was number 2. This will be 2. Let's imagine it's the number 1. This will go up. That's what we're doing right now. So I need to tell each position to go up by 1 depending on which random number has been pulled out. So it'll be number, square bracket, so number, random, now minus 1. So we want our array, the random number which has been pulled out. I'm going to talk about y minus 1 equals number random minus 1 plus 1. Okay. And that is because of Okay, I can't use, maybe I can't use random here, so let's call it randoms. Okay. It's going to put out a random number. Let's imagine it's, well, okay, there's different ways we can do this. I can say 0 to 9. And if I did that, that will work. So if it's 0, that actually means 1. So let's do it that way. So if it's 0, that updates. But in our own head, we know that means 1 at this stage. Okay. So what we've done is we incremented it. Plus 1 every time it pulls out. We've then got calculate the expected frequency, output the actual frequency. So the expected frequency, if we do 200, would be 20. That'll because each number is going to be pulled out, we're expecting 20 times. So 1 will be pulled out 20 times, 2 as it's random. So what I'm going to do is I need to first of all calculate the expectancy. So we're going to make a variable and I'll call it expectancy equals, and then it's going to be our number which we typed in, so it'll be like 200 divided by 10. And what I'm going to do is I'm going to int it, which means round it. Well, not round it, it chops up any decimal. So if we play this game now, I do print expectancy, and we were to run our code. Okay, I made a boo-boo, it's here, number, randoms, this should be randoms here, let's test the code again. 20. If I was to say, okay, let's do 300. For each number, the expectancy should be 30. Nice and easy. So, in that situation, what we want to do now is I want to just test out and see how many times each number has actually been pulled out. So I'm just going to display our list. For I in number, print I. So let's have a look now. Okay, so we've got 0, so 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so I need to make that 0 to 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so number 1 has been pulled out 31 times, number 2 31 times, number 3 22 times, number 4 35 times. So let's make that a little bit neater. The number I plus 1, because actually that's not going to work. We need to do this as a for I range. Length of number. Okay, so print the number I plus 1. So if I run this now, it will say, who doesn't like that? So, the number, comma. There we go. So I run this now, it will say the number I plus 1, the number 2, number 3, number 4. Okay, so what I'm doing is I'm doing this bit, number 1, number 2, number 3, 4, 5, 6, 7, 8, 9, 10. I now need to do what's inside of it. So, is displayed. So now if I run our code, the number 1 is displayed, number 2 is displayed, number 3 is displayed, but I haven't actually said how many times. So let's do that now. The name of our list is number. So number I. Well, it's not really displayed, but number the amount of, in fact, let's change that to the number. Let's change that of frequency is So the number 1 has appeared 27 times, number 2 34 times, number 3 30 times, number 4 29 times, etc. Now, we've got our expectancy. So what we want to do now is display the difference. So how do we do that? Well, if we look at this, it's expected 17 times. Sorry, it's expected 20 times. It happens 17 times, so it's a -3 difference. So let's do that as a calculation. So I'm going to do, and the difference is, comma, and I'm going to do number I, just put this in brackets, number I minus expectancy. So if we were to work this out, and let's do the 200 again rather than 300. So it's going to be kind of like the example we've been given. So the expectancy should be 20. So it's 16, number 1. So expectancy is, sorry, the difference is -4. Frequency of number 2 is 25. Yo! So it's +5. Did I ask us to do +5? No. Number 3, 25, so +5. 16 for number 4, so it's short on 4, so -4. So if we look at our code again, let me just zoom out slightly. I made my procedure, we're using random. I'm looping through the repetition of how many times we want it to loop. Every time we do a random number, we then simply increment the random number in its array counterpart. That's one way of doing it. There's different ways you can do it. This is probably the easiest way I can think of. So maybe this go up by 1, or this one go up by 1, depending on it. We then work out the expectancy, which is for repetition divided by 10. How could you have done that yourself? Well, if you're using your brain, we've got 10 numbers, we're doing it 200 times, so the expected frequency will be 20. Just divide it. Then I'm going to loop through our list called number, display each one of these numbers here, but I'm doing I plus 1 because it starts on 0, so I want it to say the number 1, number 2, number 3. If I didn't do I plus 1, look what happens. It'll say the number 0. It'll then say the number 1, but we don't want that. We want it to start on 1, so it should be I plus 1. But we're still checking inside I, which is 0. So I plus 1, which is 1. This is actually 1. This one is 2. This one is 3. This one is 4. But actually this would be 3 in I. And then we work out the expectancy by taking the number, what's inside, and take away the expectancy from it, and that gives us our answer.